It's a pleasure to talk about our paper named R2D2, Removing Redundancy Utilizing Linearity of Address Generation in GPUs. GPUs use a special programming model called Single Instruction Multiple Thread, SIMD, to manage hundreds of functional units and massive multithreading while also providing programmability. Each thread runs the same static code with its own context data and programmer-defined identifiers, which we refer to as built-in indices. As the figure shows, the simple CUDA code first computes the variable index using the built-in indices and uses the index twice to load and store data. The SIMD execution model has a well-known flaw. Index calculations for memory access and branch decisions introduce redundant computations across threads. In the figure, GPU must multiply the byte size and the index and add base address of the input array to access data. It depicts the thread computation generated by such computations. The blue number indicates the order of operations, and the black number shows the computation results. Every fourth thread in the first row performed the same computations with the same source operands, resulting in redundancy. We indicate the redundant computations by drawing them. Prior work have tried to detect and remove the redundant computations in the existing instruction stream to improve performance and energy efficiency. We discovered that GPUs frequently calculate memory addresses using a linear combinations, a sum of products with built-in indices and scalar values. We call this property the linearity of address generation in SIMD execution model, the linearity of SIMD. We propose that it is possible to clarify and unveil implicit redundancy using the linearity of SIMD, which allows GPUs to remove more dynamic instructions than prior words. For example, the aforementioned expression, the first line, can be developed into the second expression, the second line. In the figure, considering the second expression, the memory address calculations need 80 thread computations, but only 29 unique computations exist. Using the observations, we propose a new GPU architecture R2D2. R2D2 detects the implicit redundancy, decouples the computation generating linear combinations with software, and computes them with warp instructions as needed with microarchitecture. The figure depicts the advantage of R2D2. The baseline model shows the few redundant computations. R2D2 clarifies, unveils, and decouples the implicit redundancy. Then R2D2 computes them with warp instructions as needed. Thank you for your time, and I invite you to listen to our entire presentation and read our paper.